All right, video 17. Let's talk about some shortcuts. It's going to make your life a little bit easier. Okay, do you remember last semester we talked about triangle congruency? How we could show that two triangles are congruent? Well, some of the different theorems and postulates that we looked at were side, 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 angle, angle, side, and so on. Remember those? Well, there's some for similarity also. There's actually 3. With congruency, there were 5 different ones. With similarity, there's only 3, so that's good news. So, take a look at your first vocab word. It's angle, angle, triangle similarity. So it's showing triangle similarity using angle, angle. So, if 2 pairs of angles from 2 triangles are congruent, then they are similar triangles. So take a look at our picture here. Notice that angle A is congruent to angle D. And angle B is congruent to angle E. If you can get 2 matches like that, then that is enough to prove that your 2 triangles are similar. Easy enough? All right. Okay, next one. Now we're looking at side, side, side. So if you can show that all 3 sides are proportional to all 3 sides here, like this, then you have similar triangles. So if corresponding sides of 2 triangles are proportional, then they are similar triangles. So if you can show that side AB and DE, if we write it as a ratio, as a fraction, that is equal to AC over DF, and that's also equal to BC over EF, if you can show that all 3 of these equal the same number, then you have similar triangles. Think you can do that? I think so. It's just going to require you to be able to simplify fractions. If you can do that, you're going to be just fine as far as showing that 2 triangles are similar using side, side, side. You got this. Okay, the third one is like a combination of the other 2. It's side, angle, side. So if you can show that one pair of angles is congruent, so take a look at that. Angle A is congruent to angle D. So we have a pair of angles. And we can show that 2 pairs of corresponding sides are proportional. So AB corresponds to DE, that is proportional to AC and DF. If you can show that this fraction equals this fraction, and you have the angle in between those 2 sides, okay, notice how it has to be in between because it's side, angle, side, side, angle, side. The angle has to be between. If you can show all this to be true, then you can show that you have similar triangles. Okay, let's give this a try. Be sure to write your title and draw the triangles with all the measurements. Good idea to write out the directions. Okay, recall our 3 similarity shortcuts. We're going to go ahead and write them out. We have angle, angle, side, angle, side, and side, side, side. Those are our 3 choices for showing that 2 triangles are similar. So just looking at what we have here, these 2 triangles, do you see any angles marked? Nothing to do with angles, right? No, no, no. So we know it can't be angle, angle. And we didn't have any angles marked, so we know it's not side, angle, side. So our real choice, our only choice, is side, side, side. But we have to prove that it's side, 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 meaning that we have to show that the sides that are corresponding are actually proportional also. Okay, so here's what we need to do. we need to find the sides that are corresponding. And if you look, there's nothing marked. We don't have a similarity statement. We don't have anything. So how do we know what sides go with what sides? Where do we put the circles, the rectangles, the triangles, or the hearts, whatever it is we decide to draw? Well, here's how you do it. Go to your first triangle. We'll work with triangle ABC. And find the smallest side. The smallest side would be 10. Okay, well that would have to correspond to the smallest side on the second triangle. So it would have to go with 20. There's no way that it could be the bigger side. That wouldn't work out. Okay, then go to the next size up, which would be 15. And find the next size up on the second triangle, which would be 25. And of course, then 21 would have to correspond to 35. Now that we know which sides will be corresponding, we have to set up our fractions. And then we're going to check to see if they are proportional. So we know that 10 goes with 20. And 15, we're going to start back with the smaller triangle since we started with the 10. We have to go to the 15. 15 will correspond with 25. And 21 to 35. Okay, so in order for side, side, side to be the reason that these two triangles are similar, we need to show that these three fractions are equal. Is this whole thing true? So there's a couple different ways we could do it. We can just divide and put them in decimal form, or we can reduce each fraction. Well, I'm sure that you're going to probably want to just go ahead and punch them into your calculator. So if you open up your calculator, we would have to divide 10 by 20. So 10 divided by 20 gives us 0.5. Okay, now if the other two fractions also equal 0.5, we are good to go. We can say that these two triangles are similar by side, side, side. So 15 divided by 25 is 0.6. Uh-oh, we have a problem. Well, let me go ahead and do the other one. 21 divided by 35 is 0.6. So, because we didn't get a match for all three, they are not similar triangles. It looked like we were going to get to choose side, 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 but nope, it didn't work out. So that means we're going to have to write not similar. Bummer. We tried, but nope, not similar. Okay, those three are not equal. Okay, these two are. But this one ruined it. Oh well. Let's try another one. Okay, on to problem 2. Let's see if these two triangles are similar. Let's go ahead and write out our choices for showing similarity. We have angle, angle, side, angle, side, and side, side, side. Now, the next thing you want to do is look at what you're given. Okay, we're given an angle and we're given two sides for each triangle. So that's a good indication that we're going to be using side, angle, side. And just make sure that that angle is in the middle of the two sides. It's called the included angle, and it is where it should be. So we are good with that. So let me go ahead and cross out the ones I know I'm not going to be using. Now, in order for side, angle, side to work, the two sides must be proportional and the angles must be congruent. So if we look at our two angles, they are congruent. B and F are both 50. So angle B is congruent to angle F. So we're good there. But we need to look at the sides now. So the sides, we have to do some testing. So if we look at triangle ABC, just like last problem, we're going to circle the smaller one and then go to triangle DEF and find the smaller side. So those two we're going to check, and then 24 and 16. Now let's set up our proportion. We have 12 corresponds with 8. And we'll go back to the triangle ABC and start there again. 24 corresponds to 16. Do you remember the next step? Well, you have two choices. You can simplify each fraction and see if you get a match, or you can just punch it into your calculator and turn it into decimal form and see if those two numbers match. So I'm going to go ahead and punch in 12 divided by 8 into my calculator, and I get 1.5. Let's see what happens when we divide 24 by 16. Ooh, we also get 1.5. We have a match. That's good. So we were able to show that the two sides were proportional and that the angle was congruent that's in between the two sides. So here's what we're going to write. Yes. We have to answer the question, are they similar? Yes. Triangle ABC is similar to triangle. Now let's make sure that we get this right. Okay, so we know that B and F are the same angle, so F's going to have to go in the middle. And these two sides go together, so it would have to be DFE. DFE. Okay, so we stated that the two triangles are similar, and then it says justify your answer. So we're going to say that they're similar by side, angle, side. Yes, got it. Okay, we made it to problem 3. Once again, let's write down our 3 similarity shortcuts. We have angle, angle, side, angle, side, and side, side, side. Looking at the problem, which one do you think it is? Do you see any sides marked? No, no sides are marked. So it can't be one that has an S in it. No sides are marked. So we have to check angle, angle. Now for angle, angle to work, to show similarity, we need to have 2 sets of congruent angles. Well, we do have these 2. That's only 1 set though. I need 2 sets. So are you thinking these 2 triangles are not similar? Well, this one's a little tricky. Recall that the sum of the angles, the interior angles of any triangle, add up to 180 degrees. Remember that? Well, let's see what that angle M, let's see what angle M is going to be. Because I can find it. We can find it, right? We have 2 of the angles. Let's find the third and see maybe this angle matches this angle. I don't know. Let's try it. So off to the side here, we're going to add 102 plus 48, and we get 150. We subtract 180 and 150, we get 30. So that means that this angle is 30 degrees. So turns out we do have two two sets of congruent angles. We have 102 and 30. Well, just for the heck of it, I know that we could do the math, and this one would be 48 degrees because that would add up to 180. So it turns out all three of them are congruent, which there really wouldn't be any other way around it. If two of them are congruent, the third one would have to be. Okay, if two angles are congruent, the third angle is going to have to be congruent to the other angle. But we only need two. We only have to prove that two of them are congruent for this to work. So let's take the 30. We know that the 30, angle F, is congruent to angle M. So we know angle E is congruent to angle L, and we know that angle F is congruent to angle M. So are the two triangles similar? Yes, they are, because we showed that we had two sets of congruent angles. So let's write our answer. We'll say yes, triangle. We'll just say FEG is similar to triangle. Now F is congruent to M, and E is congruent to L, which means G is congruent to N, by angle, angle. Got it. Okay, so that's how you show that two triangles are similar using angle, angle. You have to find two sets of matching angles for that to work. It might not always just be given to you in plain sight. You might have to do a little work to show that you have two sets. Okay, so keep that in mind. Okay, I know this was a long video, but you made it. I think it's time for a dance break. Go ahead, stand up. 10 seconds. Go ahead. No? Too embarrassed? I would be too. It's okay. Have a wonderful day.